So hello, today we are going to solve this problem apartments, which is the second problem of CSES from sorting and searching. So let's see what question is saying. Question is saying we have been given apartments. Okay. So there are n applicants and m free apartments. So we have been given n applicants and m free apartments. So these are applicants and these are apartments. And n carries numbers, let's say 60, 45. We are taking input elements only 60, 45, 80, and again 60. An apartment is given as 30, 60, 75. And also we have been given something called K, okay, and it is given as 5. Okay. So the question is saying that each applicant has some desire for the apartment. They want basically 60 minus K or 60 plus K. So this is their range. They see that if any apartment comes in between this range, they are ready to buy it. So let's say for this applicant, first applicant, which is 60. So he's saying that I am ready to buy any apartment which comes under the 60 minus K and 60 plus K. So it will be 55 to 65. If any of the apartment is in this range, this guy will buy it. And similarly, we need to find the number of applicant who will get the apartment. Okay, so this is the problem. So let's see how we can solve it. The thing is that this applicant and this apartment, they don't have any relation. So we are going to sort them. We are going to sort this also. We are going to sort this also. So this is already sorted. Apartment size is already sorted, and the user will become applicant will become 45, 60, 60, and 80. So why we are sorting? We are sorting so that each individual, we want to see that what is the minimum, what is the first apartment which we can give to the minimum greedy person, that is asking for very less size of apartment. So we see that the person which have very less greed, that is 45, is ready to buy any apartment which comes under 45 minus K to 45 plus K, which will be in this case 5, so it will become 40 to 50. So he's ready to buy any flat which comes under 40 to 50. Okay. So if we can satisfy this guy, then we can only go for other guys. Okay. Because we know that this is the very less greedy guy. Means this is very less greedy person. So we will see that whether we can give apartment to this guy or not. So to see that whether we can give this guy apartment, we have sorted this number. We want apartments to be sorted so that we can find out which first we want to first satisfy the less greedy guys. Okay. So you can see that 45, for the 45, we have no range in we have no apartment within the range of 40 to 50. So we can go to we can go to see for other guys, other greater guy, that is 60. So for 60, you are going to see that for 60 will be happy if we can give him any apartment which is in the range of 55 to 65. Yeah. So there is one apartment which satisfy him, that is this 60 only. So we can say, okay, we have satisfied this guy, so our counter will become 1, and we will keep on checking for other person the same thing. Okay, so this is the solution for this question. We will use upper bound. We are going to use we are going to see that which at what point we are going to satisfy our customer. Let's say for an example, for the 60, since we don't know where this 60 is going to come, this can come after 10, after 20 times, after 30, or after 50 apartment. We don't know when the 60 will appear. So for getting 60, we are going to use binary search. And if this guy is satisfied, if we have satisfied this person at some point, then we are going to start our binary search from that very point for the next customer. And that is the solution for this question. Let's say for this 60, we have done an upper bound on this apartment, which will we will do upper bound of 59. Why we are doing upper bound of 59? We want to get greater than, oh sorry, we will not do upper bound on this 60. We are going to do upper bound on 60 minus K. First we are going to see for the very less, means first we are going to say minimum size apartment which is going to satisfy him. We are going to see that very apartment first. So we are going to do an upper bound on 60 minus K, which is nothing but 55. And since we are doing upper bound, I am going to take extra minus 1, so which will give me 54. So we are going to do an upper bound on 54. So this will give me this 60. We will come to this 60 and we will say, okay, we can give this guy this 60 apartment. Okay. Now for the next customer, we are not going to start upper bound from the starting. We are not going to do binary search after this flat, because we know that no amount of flat before 60 is going to satisfy this very customer. So for 60, we already know that there is nothing that can satisfy the 60 guy, because this 60 guy will again wanting 55 to 75, and we have already given this 60 guy this 60 apartment. So we are now going to go for 80. For the 80, you can see that 80 will be happy if we are going to give him 75 to 85 range flat. And there is one we have. So we are going to do binary search after the 60, and we will get the 75 only. And that is the very solution for this question. If you will see my solution, we're going to see that we first take an input customer desire and available apartment, whatever the available apartment we have and customer desires. So we have taken normal inputs like we do in C++. Now we have sorted independently for the customer desire and for the available apartment. And after that, we are seeing that we have set occupied equal to 0. This occupied will say that how many customer we have satisfied, or at what point we have satisfied our customer. At what means the last flat we sold, that is our occupied. That is going to that thing we are going to get denoted by occupied only. So min target distance, first we are going to start for each customer, and for the very first customer our